Imagine someone tells you that a machine has done in minutes something that, for a classical supercomputer, wouldn't be a matter of a long time. It would be a matter of an absurd amount of time, almost offensive to human intuition. We're not talking about hours or centuries. We're talking about scales that surpass any history, any civilization, even the very lifetime of the universe as we usually imagine it. And then the question that truly scares you appears. If that machine works, where does its power come from? Because it can't come only from faster chips. It can't come only from better engineering. It has to come from a deeper crack, from physics. People think they understand what it means to compute. 1 and 0, on and off, path A or path B. And for decades, that was enough, because the visible world seems to obey that logic. But the real world, the microscopic world, is not obligated to respect our mental comfort. Down there, particles do not behave like solid little balls. They are states. They are probabilities. They are something that, until you look at it, doesn't fully decide. And from that strangeness, a new kind of machine is born, one that does not think like we do, but instead lets nature do the work from the inside. In a classical computer, if you explore a maze, you choose one route. If you're wrong, you go back and try another. It's a lifetime of attempts lined up in sequence. But in the quantum regime, exploration is not a line, it's an expansion. It's as if the system could unfold several paths at once, not as a poetic metaphor, but as a physical property of the state itself. That's why qubits are so unsettling. They are not limited to being 0 or 1. They can exist in a mixture, a superposition, a combination that cannot be reduced to a single decision until the very end. And when you combine many qubits, the number of possibilities grows brutally. It doesn't grow a lot. It grows exponentially, as if reality were hiding an entire ocean behind a single drop. And here is the part that fires up the imagination. If a quantum system with n qubits can represent 2 to the power of n states, then a classical machine would need a ridiculous amount of memory to keep up. With just a few dozen qubits, you're already brushing against limits that for classical systems are a wall. With hundreds, you're talking about something that seems larger than the observable universe. So the question returns with greater force. If there aren't enough atoms or bits in our universe to sustain that calculation classically, what is really happening? At some point, to sustain that power, you have to accept that what we call calculation is not just a process inside a box, it is a negotiation with the very fabric of reality. And the oldest clue to that negotiation lies in one of the strangest experiments ever performed, the double-slit. You fire photons one by one as if they were tiny marbles of light. You expect them to choose one slit or the other, 2 paths, 2 bands, simple. But no. An interference pattern appears as if each photon had gone through both paths and interfered with itself. And when you open more slits, common sense collapses completely. Regions. That should brighten go dark. You add more light and get less light. It has no permission to happen. And yet it does. The comfortable explanation says it's a wave. But that comfort doesn't last long, because when you try to observe which path it takes, the pattern changes, as if the act of looking modifies the story. And then the disturbing idea emerges. Maybe what interferes with what you see is not the same photon, but something you cannot detect directly, whose presence is revealed only through its push. Something not in your visible world, yet affecting the result. Something that acts like a physical shadow, real in its effects, invisible in its presence. If that is true, what we call interference stops being a mathematical trick and becomes a collision between realities. As if, when passing through the slits, there were not a single trajectory, but a fan of real trajectories coexisting without fully mixing, yet mixing enough to push the final outcome. And there appears the concept that divides people, many worlds. Not as science fiction, but as an attempt at explanation, not universes for stories, but universes as the price to pay for a theory that works without patches. From here on, quantum computing stops being merely a technological advance and becomes a philosophical argument with bolts and screws. Because if a quantum machine solves certain problems where classical methods collapse, then perhaps its power does not come simply from doing things better, but from using a resource the classical world does not have. The most incendiary hypothesis says that those calculations are distributed in some way across multiple branches of reality, as if the work were being done in parallel within a structure larger than our everyday universe. It's not that you travel between worlds, it's not that you can send messages to your other versions, it's something colder and deeper. Physics allows interference, and that interference is precisely what these machines turn into performance. And while that idea still sounds like madness, engineering keeps advancing. More stable quantum chips are being built. They are subjected to tests designed to humiliate classical systems. And when an experiment produces a result that, translated into classical time, becomes almost infinite, what's at stake is not just who has the best lab. What's at stake is which interpretation of reality survives contact with technology. Now comes the part that generates the strongest retention, because it becomes personal. If many worlds are real, then not only are there particles in multiple states, there are versions of you diverging through microscopic decisions you will never notice. Not clones you can visit, but stories that split and never cross again. The question is not, can I travel? Because, as far as we know, the practical answer is no. The more unsettling question is, what does it mean to be me if reality branches? Are you the same person you could have been, or are you the result of one specific line among infinite ones? And if you cannot change lanes, what meaning do choices have? The paradox is that even if you cannot communicate with those branches, the physics that allows them might already be in use today, inside a machine. Not to explore alternative lives, but to produce results here. So the multiverse, if it exists, wouldn't be a spectacle. It would be invisible infrastructure, a silent part of nature working without asking your permission. And then, suddenly, the everyday world changes texture, because simulating nature stops being a pretty phrase and becomes a warning. Nature is not classical. If you try to force it into a classical mold, you fall short. If you build a machine that respects its rules, the reward is enormous. And the explanation of why it works pushes you toward a place where the word reality no longer means what you thought it did. So the next time you hear that a quantum computer performed an impossible calculation, don't imagine it as a trick. Imagine it as a signal, a message encoded in hardware that says, the universe you thought was unique might not be. And if that conclusion makes you uncomfortable, perfect. That's where it gets interesting. If these machines keep improving, they won't just change technology. They will change the oldest question of all. What kind of world is this? And how many worlds stand behind it? If you made it to the end of this video, comment, "I've arrived," and I will personally reply to you. And if this resonated with you, subscribe to be part of it, and leave a like if you enjoyed it.